All right. Well, welcome back, everyone, to our grain conference. And we're excited to have everyone back with us this week. It's been some beautiful weather here in the Northeast. So I imagine some folks are going to be out in the field as we are as well up here, getting ready to plant grain. And looking at all of our spelt. Actually, Sylvia, I was out checking out the spelt today, looking to see how it overwintered, and overall the grains look really good for the most part. So that's exciting. And I'm not sure, I'm excited to be getting ready to plant grain, but it's a little early, feels odd, but nonetheless, time to plant when the sun shines. It's time to make hay,
sure
as they say in Vermont. All right. Well, to get rolling this afternoon, we're going to have three speakers speaking about spelt, the history of spelt, a little bit about the grain itself and some of the work that we're doing here at UVM, and some of the seed saving and propagation work that Sylvia has been doing, followed by Elizabeth Dick, who many of you know Elizabeth from past grain conferences. She works, she runs Ogrin over in New York and works with many organic grain growers throughout that region, and has done a lot of work with spelt and looking at ways to hull it on a smaller scale so that we can grow even more spelt and make it available to our end users. So Sylvia, welcome this morning, and I'm going to let you work on getting your presentation up. And it's been great to work with Sylvia. Sylvia has been saving seed now for how long, Sylvia? And evaluating all different types of grains.
Yeah, the whole seed saving has probably been about 28 years. And I think the grains have been 10, maybe 10 or 15 of that.
Well, it's been wonderful to work with Sylvia. She has brought to us so many wonderful varieties, spelt, and now some hulless barleys that we've been working on. And it's been great to be able to increase that seed a little bit, and now moving some of it out to the farming community. So thank you so much, Sylvia, for your work. And we're so glad that you could join us today. Sylvia's gonna talk, and then Henry, who works here at UVM with our Northwest Crops and Soil team, and also has a long history of working with grains and marketing grains, cooking with grains, will present after Sylvia. And so they are gonna have you type your questions in the chat box, and then we'll answer those following their presentations, just kind of like we have been doing. We'll take a few questions, and then we'll move on to Elizabeth, and I'm sure we'll have time at the end for more questions for everyone. So Sylvia, I'm going to let you take it away. I can see your screen.
Great. Thank you so much. Thank you, Heather, and thank you everybody who has worked so hard to make this whole grain conference such a wonderful success and such a rich experience. So I am going to talk about spelt, and I just want to start by saying, how often have we wished that we could time travel back to some watershed moment in history and witness an event that would have repercussions from that time forward. And yet, when it comes to agriculture, there is seldom one identifiable moment that could pinpoint, say, the emergence of a particular species or variety. So archaeological records shine some light on these questions, but even they are often subject to revision as new evidence is discovered. We simply have to accept that there's often an element of mystery that cannot be resolved. And certainly this is the case with the emergence of spelt. There are at least two narratives. So the earliest archaeological evidence of spelt occurs during the Neolithic in the mountains of Western Georgia and Eastern Turkey. And I don't know if you all can see my arrow, but there's this highlighted area there. And so that's where the earliest emergence of the so-called Asian spelt occurs. And that happened between about 6,000 and 5,000 BCE. And it was the result of a hybridization of a tetraploid domesticated emmer, the Triticum turgidum subspecies dicoccum, and a wild goat grass, the Agilops tauschii. And here you can see a chart. Now, this is the presumed evolution of spelt from an ancestral wild diploid. And as I was saying a moment ago, there's still considerable conversation and dispute and controversy over what the exact path was and what the exact wild goat grasses were that were involved. And certainly certain ones still appear and are growing in the wild in different regions. So, but this is sort of the current thinking. And so what was involved was the domesticated emmer, the Triticum turgidum subspecies dicoccum, and that contributed the A genome. And then the Agilops speltoides, which contributed the B genome, and that was another goat grass. And thirdly, the Agilops tauschii, which contributed the D genome and forming together the hexaploid spelt. So this map shows you some of the earliest occurrences of the spelt and then how it moved westward into Europe. And I think the black dots represent archaeological finds from around 5,000 to 3,500 BCE. And I think the blue dots actually represent the first occurrences of the European spelt between 3,400 and 1,700 BCE. And the red dots up there in Denmark will represent 1900 to 1600 BCE. So spelt is a captivating grain for this and many other reasons. Toward the end of the Neolithic, around 3000 BC, spelt emerged separately in Europe, and it's the only one of the ancient grains to have done so. So whether these are in fact two separate areas of origin has been controversial, and there have been various studies aimed at determining the exact provenance of the European spelt. In fact, one in particular has identified a slight difference in the DNA between the spelts from the two regions, which would rule out that the Asian spelt had wandered westward from Asia into Central Europe. So as far as the European spelt is concerned, this now points to a so-called introgression or a hybridization. And candidates for this on the one hand are the domesticated emmer group of tetraploids, the Triticum turgidum, hardwheats, which include the hulled subspecies Dicoccum, Paleococcum, and Ispahanicum. And all three of these have elongated slender seeds similar to that of spelt. However, exactly which tetraploids were involved cannot be conclusively determined. I just want to say quickly, this is Rouge de Gruyere. It's also called Popeliweizen. It's a Swiss variety that has incredibly long, there's an incredibly long, almost a 3-foot distance between nodes on this particular grain. So it was one that was often used for straw weaving and hat making and other crafts like that in Switzerland. So the cross that created the European spelt probably involved a free threshing hexaploid club wheat, of which this is an example, the Triticum aestivum subspecies compactum. And a prerequisite for this cross was, of course, the simultaneous cultivation of both emmer and club wheats. This was the case toward the end of the Neolithic, when a free threshing wheat, which wandered in from the Mediterranean region, and an emmer from the Danube region came together in southern Germany. As such, spelt has a foot in each of two eras of wheat development. The more ancient emmer contributes depth of flavor, nutritional richness, and ease of digestibility. From the more modern wheat, it gains its excellent bread baking qualities. About 1100 to 800 BCE, spelt enjoyed wide cultivation in Central Europe, from the Southern Alps to Denmark and Sweden. In the lake dweller settlements of southern Germany and Switzerland, spelt became the primary grain in cultivation. And here you can see all of those red dots represent locations where there were pile dwellings that where archaeological finds exist of the occurrence of spelt. And you can just see the faint outline of the national outline of Switzerland there, and Germany to the north, France to the west, Italy to the south. So here we go. In the lake dweller settlements of southern Germany and Switzerland, spelt became the primary grain in cultivation. In the pre-Roman era, spelt was spread further by Celts from Switzerland to southern England. And then during the late Iron Age, spelt became firmly established in the 3 regions in Germany that even today remain the most important centers of spelt cultivation in that country. And even though it subsequently disappeared from much of Europe, its significance remained in Switzerland and in Swabia and the Mosel regions of Germany. And then this is where Hildegard von Bingen, the medieval Benedictine abbess, composer, writer, philosopher, and mystic, learned of it and praised it as good food and superior to bread made from rye or barley. Spelt is the best grain, she wrote, high in fats and powerful and more digestible than all other grains. For those who eat it, it builds body and good blood. The soul is made cheerful and lighthearted, and however it is prepared, whether as bread or some other food, it is good and delightful and sweet, she wrote. So I'd like to talk now about the development of spelt cultivation in Central Europe, partly because my own roots are firmly planted there, and partly because varieties from this region carry cultural history and have the best capability of adapting well and thriving in our reasonably similar latitude and climate. And more specifically, I'll focus on Swiss spelt cultivation since, with the exception of the Pelzodenko, that's the origin of the varieties that were trialed at UVM last summer. Barley, einkorn, and emmer were the earliest grains to be cultivated in Switzerland, followed in the Bronze Age by spelt, by which time it was the most commonly grown grain. The village of Cortaillot in Western Switzerland is an archaeological site from the so-called Bell-Beaker period, which dates from about 2750 to 2500 BCE. And cereal plant remains from this site were predominantly spelt, but also emmer, corn, and probably barley. It's possible to analyze these remains since the grains were burned and the residue does not biodegrade. The abundance of spelt represents a fundamental change compared with the plant finds from earlier sites of the region. And just to help you locate yourselves, this little X marked line here, that's the boundary with France. This is the Lake of Neuchâtel, so we're way in the western part of Switzerland. Let me see if I can get my cursor over to the slides again. There we go. Sorry for that. So here's a map of Switzerland and showing the locations of the canton of Graubünden here in the southeast. Surprisingly, evidence of spelt cultivation during this time has been found at very high elevations in the Alps. Both grains and threshing residue have been found at several locations in the canton of Graubünden in the southeastern part of the country. And once again, I'm sort of losing my cursor. There we go. So this is an enlarged map of that canton showing the locations of the villages that I'm going to talk about. And they are identified with those red dots. There's Malados and south of that Lange, Savognin, and then Schulz. So in Malados, spelt remains were found at 3,281 feet. And I just wanted to give you a sense of what the landscape looks like there. And it certainly isn't the kind of landscape that we think of when we think of grain cultivation. In Savognin, which is on the access road to the Uller mountain pass, remains were found at 3,960 feet above sea level. In Squol, in the lower Engadine Valley, at an elevation of 4,232 feet. And in Lange at 4,357 feet. Plant residues from the Iron Age have been found in Lange at an elevation of 4,357 feet, representing some of the earliest evidence of spelt cultivation in Central Western Europe. Although spelt's inherent cold hardiness and its tolerance of relatively poor soils and moist circumstances help explain its suitability to these regions. In the late Middle Ages, Spelt comprised up to 65% of the grain cultivation in Switzerland. Other than in the southern Rhine Valley, bread wheat offered no viable alternative since it was too demanding and needing of warm conditions. Then suddenly around 1400 and the beginning of the Little Ice Age, with its cold winters and cool, wet summers, Spelt and its tolerance of these conditions became a star. Farmers learned to sweeten acidic soils with calcium-rich marl, which is a carbonate of calcium and magnesium, thus improving it for Spelt cultivation. And Spelt remained the most important grain in southwestern Germany up until the end of the 19th century. By the beginning of the 20th century, cultivation of Spelt had begun to decline, and exacerbating this trend was the post-World War II general increase in wealth and the accompanying preference for white bread. Additionally, breeding had increased both cold tolerance and yield of the bread wheats. So the final blow was dealt by modern industrialized mills doing away with their dehulling machinery. Spelt foods, however, remained part of the farmer's diet, though, in simple preparations such as porridge and Spelt spätzle. Before the middle of the 18th century, there were no systematic descriptions of Spelt varieties in Switzerland. However, after the famine of 1770 to 1771, there was suddenly an incentive to devise scientific methodology for describing individual varieties so that the results of comparative trials could be analyzed in a meaningful way. In 1774, Albrecht von Haller first described the 4 basic phenotypes of Spelt grown in Switzerland at the time. So there was the awnless white-hulled, the awned white-hulled, the awnless red-hulled, and the awned red-hulled. And all 4 of these types carried reddish-brown grains. By the middle of the 19th century, Spelt had virtually disappeared from the Alps of Graubünden. Over the course of the 19th and 20th centuries, it was replaced almost entirely by bread wheat. As late as 1912, only Spelt land races were being cultivated. At this point, the index of the National Plant Commission in Switzerland described only the various Spelt types, but did not indicate individual regions of origin. So targeted breeding had begun in 1908 with a significant participation of farmers. No other crops had involved the participation of farmers, as opposed to formally trained scientists, in the selecting and breeding process to the same degree. In the case of other grain crops, it had been primarily the agricultural schools and the agricultural projects of prisons and asylums for the mentally ill that had conducted this work. I found that kind of a disturbing and shocking sort of a thing to read. At first, strains were chosen from among widely varying populations of the land races. And then these lines were subsequently improved through selections. A further targeted selection took place in the 1930s, which resulted in an additional narrowing of the officially recognized lines. No spring Spelt varieties made it into this new list. Muri Rotkorn, which by the way was part of the UVM trial, a winter Spelt, is one of the few that survived. And Oberkulmer Rotkorn, which I think currently is still the most widely known and grown variety in our region, was also recognized at the time. As there were attempts made to select varieties suitable to cultivation in the Central Plateau, it was discovered that many of the land races from the higher regions did not grow well in the lower regions. Switzerland is pretty strict about naming varieties that are included in the National Register and therefore are permissible for cultivation. But exceptions were made for varieties that performed well in marginal areas where others would not thrive. So I'd like to talk for a minute about the physical properties of Spelt. Spelt varieties are without exception quite tall, which helps to shade out weeds. There are both, as I mentioned, there are both spring and winter varieties, although the spring varieties fell out of favor since they were less productive than the winter varieties. The awned varieties were also dropped in favor of the awnless ones, since the unusually tough awns tended to clog the hulling machinery. There are two main types, the so-called red corn and the white corn, but this refers to the hull color and not to the grain. Stems are very strong and upright, which means there's little tendency to lodge. They are often incredibly beautiful, as you see here, ranging in color from tan through green, red, and purple, all on the same stem. And then there are two different types of spikelet formation on the rachis. There's the very tightly arranged, very compact arrangement, and then the looser or more widely spaced spikelet formation on the rachis. And I'd like to talk a little bit about spelt cultivation in the US. Spelt was brought to the US in the 1890s by German and Swiss immigrants to Eastern Ohio. It seems that the major concentration of spelt cultivation today remains in Ohio, although spelt also arrived in Pennsylvania, where among the Pennsylvania Germans, it was the only acceptable flour to use for pretzels and gingerbread. This is Mark Carlton, who was a plant explorer extraordinaire for the USDA. He actually traveled to Russia and traveled around Europe also extensively. And he was looking primarily for wheat varieties that would thrive in the plains. He originated in Kansas. And so that is the area of the country that he was primarily interested in. So at the beginning of the 20th century, spelt was grown primarily for livestock feed in the US. But as late as 1916, Carlton, in his book, The Small Grains, described 6 varieties he recommended to the agricultural student. Among them were spring and winter varieties, awned and awnless ones, and most intriguing of all, a few described as blue winter with blue-gray chaff, velvet spring bearded, and blue velvet bearded. So there has been a considerable increase in interest in spelt in the last 10 or so years, and contributing to the current surge in interest is a confluence of benefits for both the public and the farmer. As consumers, we are paying more attention to healthy eating and to spelt's nutritional richness, its flavor and digestibility, through greater demand for breads made from spelt. And we're learning about its versatility. There's also been a rise in organic farming practices in the US, and spelt with its disease resistance, cold hardiness, drought tolerance, adaptability to a wide range of climatic and soil conditions, and reduced need for pesticides and herbicides make it an outstanding candidate for organic gardening. And planted at certain spacing, some varieties have the ability to tiller heavily, resulting in some weed suppression and, of course, greater productivity. But also of importance, and this I found very interesting to read, is that the hull protects the grain from contamination by pollutants in the atmosphere. The nutritional profile of spelt is really impressive. According to one scientific article, spelt contains all the components necessary for proper functioning of the human body. The nature of its unsaturated fatty acids makes it beneficial for lowering blood cholesterol levels. Compared to other cereals, spelt is high in phosphorus, zinc, copper, and selenium. It also rates above average in boron, iron, magnesium, manganese, and sulfur. It's exceptionally rich in B vitamins, but also in A, D, and E. The protein levels are comparable to bread wheat, but amino acid levels are higher and more diverse. And the structure of the starch makes it more digestible. Finally, spelt is 40% lower in phytic acid than bread wheat, and phytic acid locks up the absorption of phosphorus in the body. So as far as my efforts to collaborate and to bring back heirloom varieties to wider cultivation are concerned, last year I was absolutely thrilled to be able to provide UVM with spelt seed for their variety trials. And included were the Rotenburger Rotkorn, which is a selection of a landrace from Lucerne, and Altgold, which is in lower right, sheaf in the lower right, it's a very old variety, and it's from Aargau, which is also in the Central Plateau. And Gukisberg, this is Gukisberg growing in my garden. This is a white bloomed spelt, and it is a landrace from the region of Burn. So this is was collected in a field where there were at least 7 different phenotypes. So this is actually just one selection out of 7 that occurred in that landrace. And this is the Gukisberg after harvest. You can see the formation of the spikelets on the head and some of the dehulled seed. And then Muri Rotkorn, which was the variety that I mentioned earlier, which is a cultivar from the region near Bern. And cultivar is in quotes because I read several of the varieties described as such, but I think my thinking about this and about the definition of pure line is that these are basically selections that were made from land races originally. And so cultivar basically just refers to a further selection from the land race, not necessarily a cross of 2 different varieties. And finally, this is the Pelzodenko, which is the spelt from the Palatine region of Germany, which is in the western part of Germany, central, close to the border with Luxembourg. And this is the spelt that was specifically named for use in pretzel flour and in the making of gingerbread. And it was brought to Pennsylvania by settlers. So we're actually just discovering the huge range of varieties that are still in existence. The Swiss Gene Bank, for instance, lists 233 accessions of Swiss varieties. Grin lists approximately 113 accessions from Switzerland alone, and about 170 from Germany, in addition to many from other European countries, namely Austria, Spain, Belgium, Bulgaria, Romania, Serbia, and Iran. And of course, Iran is not a European country. It just slipped in there. It's tempting to request seed of all of them and conduct a massive trial to identify the best ones for cultivation in Vermont. Unfortunately, the available growing space in my own garden won't permit this. So I'm very interested in getting seed into the hands of farmers who are willing and able to grow larger plots. So in addition to varieties that I've shared with UVM, I've sent seed to the main grain alliances, Rich Rogers, and to growers in New York State, Indiana, and Wisconsin for trialing, increasing, and eventually further distribution, which is the ultimate goal, so that we can appreciate these marvelous grains. And here's the Pelzodenko growing in my garden, and I hope you can see what an irresistible and beautiful grain it is, even just simply from the aesthetic point of view. And of course, there's the great diversity. Thank you.
Wow, that was great, Sylvia. Thank you so much. That was really wonderful to hear all the history about the spelt and the spelts that we have received from you from UVM. So that was really wonderful. Thank you. All right. So if there's a couple of questions for Sylvia right now, we'll take those. And some people are wanting to contact you directly, Sylvia. Is that okay? It sounded like it was earlier.
Yes, it's absolutely okay. I love corresponding with people. And if you would like to put my email up on the chat, or I could do that.
Yeah, we'll put your email in the chat box.
Great.
So people have it. Great.
Yes, I definitely welcome people getting in touch with me.
Great. So we'll put Sylvia's email in the chat box for folks. And Henry, if you want to transition to your slides, we can do that. And again, if anybody has a question, type that in, and we'll make sure that we ask Sylvia. And Sylvia, how much spelt is grown in Switzerland today? Is it still, doesn't sound like it's as popular as it once was?
Well, it has enjoyed a tremendous comeback in Switzerland as well. And I'm not sure of the exact acreage, but it has traditionally been, it's something that in health food circles actually never really fell out of favor. And another use that has been common for spelt is that the hulls have the ability to retain warmth. And so people fill little pillows with spelt hulls and use them, warm them maybe in a microwave or something like that, and use them, for instance, to ease neck pain or something like that. So it's one of these wonderful grains that has tremendous versatility, not just as a food, but also the byproducts of it.
That's great. Thank you. And thanks for taking all the time to work with these grains and to share them with others. All right, Henry, are you ready?
Yep.
All right. Okay, we'll let you take it from here.
Hello, everybody. Thanks for joining us again today. My name is Henry Blair, and I'm a researcher with UVM Extension. And I'm just going to highlight a little bit of our work so far with the spelts that Sylvia has shared with us. This was just our second growing season with them. So the first year we grew them, we collected some harvest data, and last year we had enough grain available to do some quality analysis in the lab as well. So it's still a fairly new crop for us to be testing, and we're getting oriented to it. But this is what we've found so far. So these are the 5 winter spelts that we planted in September 2019, and they were harvested July 2020. Sylvia just took us through some of the details of where they each came from. In the field, we measured the heights right before harvest. They came in around 120 to 130 centimeters, roughly 4 feet. And that's in the ballpark of the rye varieties that we had in the field also. So they're pretty tall grains. The heads seem pretty heavy on the straw, but we didn't notice too much lodging this year. And they were harvested July 20th, which was at the same time as the spring wheat trial, but it was a much lower grain moisture than the spring wheat. So we see our harvest moistures here were in 10 to 12% range, which is good for storage. We like to see grain moisture below 14% for storage. For comparison, the spring wheat trial that was harvested that same day was closer to 18 to 20%. And the spelt trial we harvested about a week before the rye variety trial. So it was ready to come off the field earlier than rye also. And the yields were pretty good, between 1 and 2 tons per acre. And I'll discuss, in the next slide about the grain quality, but these measurements were taken with the hull on the grain, and that's it's a significant portion of the weight of the kernel when doing test weight and moisture. We'd like to look into it more this growing season, and maybe Elizabeth will have some notes to add on this. We know for barley, the hull comprises about 12 to 13% of the grain when it's harvested, and the spelt hulls are much more significant. So I'll have to take a look at how much hull there is to actual harvested grain. In the lab, we tested for crude protein and falling number. We've read in other research that protein values for spelt can reach about the same as common wheat or bread wheat in the 15 to 17% range. Ours measured closer to 8 and 9%, as you see in the chart here. And gluten proteins are in the grain. So for individuals with celiac disease and gluten allergies, this is still, those proteins are still in the grains, but it's a weaker structure. And as Sylvia mentioned, many folks find it a little bit easier on the digestive system, a little bit more manageable if there are intolerances or discomfort with higher gluten bread products. The dough, a lot of bakers say it's very extensible. It rolls out very nicely. You can really stretch out the dough, and folks don't find that it snaps back on itself too quickly or too readily. I've had a number of different pasta products and crackers and pizza crusts with the types of doughs that you would really stretch out, and they would hold together pretty well. And not quite as elastic. And then the falling number, also in the 200s, 250, which is good quality for that we see in bread wheat. That indicates pretty low pre-harvest sprouting damage in the kernel. And again, with the hulls, these samples were ground with the hull on the grain. And so the protein in the falling number was measured with the hull intact. All of that extra material being measured is likely going to lower the protein values and lower the falling numbers than we would see in a dehulled grain. So it's likely that as far as baking quality is concerned, and when comparing to, say, a wheat, that those real protein values and real falling number values are probably higher. So hopefully we'll be able to experiment a little bit this growing season and get some dehulled grain and compare the two, looking at the volume and the weight differences, and then seeing how it affects the protein and the falling number measurements. So we'll try to piece that together this season, and maybe we'll have some other data showing that next year. These are additional varieties that we planted in last fall, last September. They went in about the same time as all of the other winter grains in this region of Vermont. It's late September. So this trial was planted September 20th. We have the same varieties, same 5 that Sylvia shared with us, and then we added 4 additional varieties from a collaboration with Cornell on an OREI grant. So this year we'll have 9 varieties total to work with. And again, we'd like to test both the hulled and the dehulled grain. So this is an image of Heather loading a grain seeder out in the Northeast Kingdom, where we took some of the harvested grain from last year and planted it in larger strips at a farm up in northern Vermont. So this is an effort to increase some of the seed availability from these varieties that Sylvia shared with us, and see how they do on larger plantings on other farms. I don't have it in my notes. I believe this was alt gold that was planted out there. Maybe Heather can correct me if I'm wrong. But we have a few pounds of seed of each of these, and then as the growing seasons progress, we'll be able to bulk those up a little bit if other farms would like to try them out on and that's really what I have from this from last season, and then we'll see if we can add more to this next year as we learn more. And that is a nice one to keep in the back pocket.
Nice one, Henry. It's great. Have you heard that joke before, Sylvia?
I have not. So I'm happy to add it to my meager grain repertoire of jokes.
I'm a big fan of the grain puns, so
Yeah.
nice to have some
Thanks.
handy.
Thanks, Henry. That was great as well. And one thing I was going to add about the trials is how strong the grain is. And I'm sure you've noticed that as well, Sylvia. I'm always amazed that it doesn't lodge.
Mhm.
It's very strong. And one of the varieties, I'm trying to remember now off the top of my head, I want to say it's alt gold, always has a tiny bit of lodging, but for as tall as they just are super sturdy.
Right, right, exactly. I think that's one of the fundamental characteristics. And it's definitely a very positive one.
Yeah. Elizabeth, I see you have your hand up.
Yes, wildly waving it here.
Yeah.
Is the University of Vermont going to lead the way in terms of doing spring spelt trials anytime soon? Or have you done them?
I did a long time ago, but I definitely would be interested, Elizabeth, if you have some suggestions.
I do, but they're in the closely gripped hands of some of the Western Canadian researchers. So, but if we could, there's supposedly a couple of, well, there's one called Origine. I know that's floating around in Quebec. But anyway, maybe we could talk about that, because that would be
Yeah.
great. I know you do way too much, but that would be exciting.
We have had growers that are sort of standard spring grain growers that really want a spring spelt. And I have also noticed this happened one year, Sylvia, when we were growing the spelt from you. It was from 2018 to 2019, we experienced 100% winter kill on the spelt.
Oof.
And I was actually really shocked by that, because it had been and seemed to be very, very hardy. And of course, we had horrible winter kill in all of our grains that year, but it was patchy. Like even in the winter rye, we saw sort of this patchy winter kill, but in the spelt, it was everything. And I was really shocked by that. So it just kind of made me wonder. We haven't, like I said, it was that 1 year. But yeah, just,
I don't know.
You haven't seen that.
I've never seen that. And again, spelt is one of its things that's noteworthy about it is its cold hardiness. So that surprises me. And I don't know if what the snow cover was that year, or whether there were wildly fluctuating temperatures at the end of the winter and early spring that might have heaved up the soil in any way, or some other factors that could have contributed. But I'm not sure that I would, condemn a particular variety simply based on your experience from 1 year. But that definitely sounds unusual to me. And I've never experienced that in my garden, although I'm quite a bit farther south than you are, and probably at least one zone warmer.
Yeah. Yeah. And it wasn't any particular one either. It was just across the board. And it was a lot of grain. It wasn't just those spelts. I was surprised, but obviously one year out of the years that we've grown it, and it's been quite a few now. We started growing that grain at Brent Beidler's, actually, and that's how we started increasing the seed. So Elizabeth, I see you have your hand up.
I'm sorry, I'll shut up now.
No, it's great. It's great.
I also wanted to bring up with Sylvia what is to me a little bit disconcerting tendency, at least in the United States, to want to hybridize wheat and spelt. And I wondered if she knew anything about what is, those of you that grow spelt and occasionally buy seed in this country are probably familiar with French's seed company in Ohio. Probably you are, Heather.
Yeah.
That's one of the few places you can get commercial spelt seed.
Mhm.
And it's some of those lines. I mean, they have some great spelts. It's a little bit worrisome whether they're true spelts or not. And
always
I'm
hear
wondering
that.
if anybody's doing any investigation on that, because I think it's a shame to it's fine to do that, but then be honest about it, you know, if it's a true spelt or not. So yeah. Anyway.
Yeah, I've heard that for a while with I don't want to name out any varieties, but it definitely seems like I've heard that about a few that are out on the market.
Yeah, it'll be interesting to find out more about that. And
Yeah.
I wish we had more spelt breeders in this country. That would really help us out.
Do we have any spelt breeders?
I think we just have those associated with French's. Yeah.
Yeah. Okay.
Where their program is. Yeah.
Yeah.
Anyway, I'll shut up.
No, that's great. We did have one question about the falling number. And Henry, I didn't know, we have talked about the falling number quite a bit during, our presentation. So maybe just a quick overview. And I see that Catherine also put a fact sheet in the chat box.
Yeah. Thanks, Catherine, for sharing that. I was just looking forward to. So falling number is it's a measurement of it's a measurement of pre-harvest sprouting in the grain kernel. So what we do is take the flour and we make a slurry with water in a test tube, and it goes into a machine, and it times in seconds the amount of time it takes for the plunger to fall through the slurry to the bottom of the test tube. And the falling number is that time in seconds. So in lower falling number means the plunger fell through more quickly, and there it indicates higher sprouting damage. And a higher falling number means the slurry was thicker, it took longer for the plunger to fall through, and that indicates less sprouting damage. So what can happen is if the grain is left in the field for too long and there's any rain events or humid weather, the kernels can start to sprout on the stem and create the growing process of a new plant. And that can impact bread quality, fermentation times in wheat and barley, and it can affect malting quality. So you want to have a higher falling number, and their optimal ranges on the fact sheet that was shared for some different grains. It is a measurement of the slurry, which indicates enzymatic activity, which indicates sprouting damage.
Super.
Explain that better in the past, but
well, there's a whole fact sheet that
version of
Henry
it.
helped write, and people can read up on that.
Yeah.
So, all right. Well, with that, Elizabeth, are you ready?
Yes, I'll get my screen shared here.
Okay.
Whoops.
Well, Elizabeth is getting her presentation up and going. Just a reminder that we have another webinar tomorrow with Jeffrey Hammelman and Sylvia back at the King Arthur Kitchen. And I believe tomorrow you're making pretzels. Is that right, Sylvia? Oh, she's muted.
You're muted, Sylvia.
Sorry about that. I had already muted. Yeah, Jeffrey will be making the pretzels, and I will be demonstrating a 100% spelt bread.
Oh, great. I was, and every time we've had these baking webinars, I've wished they were like 4D, you know, where you actually get to smell, like you could puff the smell through the computer or something.
Wow, and taste, of course.
Oh yeah, well that too. I felt like that was unrealistic. I thought what was realistic was the smell, the puff of the smell coming through the computer. Anyway, all right, great. Elizabeth, tell us how we're gonna dehull this spelt so that Henry and I can get better data.
Yes, but before I begin, there may be some method to your madness in looking at it, looking at the grain quality, both in terms of with the hull and without the hull. Because I was talking to some North Dakota food scientists who have actually determined that a lot of the good stuff in emmer for people, especially with diabetes, is almost entirely in the hull.
Oh wow.
Bring some
Okay.
of that hull in there is a good idea. Anyway,
Not
I
a bad thing.
digress. I digress.
All right.
Okay, so I'm going to talk to you about progress in affordably dehulling spelt and other ancient wheats, because I can't keep my mouth shut. My name is Elizabeth Dick, and I coordinate OGRN, and I was very lucky to participate in the 2015 Northern Grain Growers Association when I reported on ancient grains, and I tried to give you a state of the art, or a lack of art, of how we were trying to process these babies. So if those of you that listen to that presentation, you can now compare and contrast and see how much progress we've made. I think we've made a bit of progress. Okay, before I go on, I would just want to thank Annie Sayre. This is funded in part by an Annie Sayre Research and Education Grant and the Chobani Community Impact Fund. And I like to start with, why the heck are we worrying? Sylvia gave us some excellent reasons why we're messing around with grains like spelt. But I can't resist. We're doing some marketing research here on the various ancient grains and some heirloom grains. And so I just wanted to make the point that spelt and other ancient wheats, and here's our latest price list. Remember, I'm working in for this particular grant, I'm working in 4 very rural, poor counties in southern and central New York. But this is our price list, and people are buying this grain either as berries or flour. So it's been quite wonderful that I actually haven't been telling farmers the wrong thing, that in fact these grains do appear to be profitable if you can process them affordably. And compare this price list, which is for our 4 relatively impoverished counties, with some of the retail prices in New York, Pennsylvania, New Jersey, which of course can be much higher depending on the market. So one of the growers I work with in New Jersey, for example, sells einkorn berries at $7 a pound in a Philadelphia market, and it's easily sold. So these are potentially very profitable grains, but of course the underlying reason for all this is that spelt and other ancient wheats conserve and improve the soil. They require low to moderate fertility compared to a lot of the modern small grains. They're highly nutritious. We've talked about this a little bit before. Spelt has a yield potential close to that of wheat, always remembering that that's in the hull. And I'll talk a little bit more about this in a few minutes, answer Henry's question a bit. And then of course we've talked about the fact that spelt is one of our hardiest grains, which is why Heather's anecdote is very puzzling. Before I go into dehulling, I just wanted to make, some of you may be aware of this, but most of the information that I get that's very good to share, I get, of course, from farmers. And a couple years ago, folks were asking me about the Sosnowski cleaner, and I'm always on the lookout for new cleaners that are worth the money. And I'll go into that in a minute. But this Sosnowski cleaner, growers are really interested in because it's relatively cheap. This particular model, which does 3,000 pounds an hour, costs about $3,000, which for a new cleaner is pretty good. Notice that there are no screens. It's just a centrifugal airflow. You're separating on the basis of density. And I've I bought one for the project, and I've been carting it around to farms. People have been trying it out. And so far, the only grain it doesn't do well with is buckwheat. It's too harsh for buckwheat. It starts to first dehull it and then to mill it. But all the other grains, it works well with. Plus, it seems to be very good for getting out green material. If you harvest a field that has a lot of green material in the combine bin, you know that that's very dangerous in terms of destroying your saleability of that crop. You have to get that green material out of the grain as soon as possible. That usually is done with a rotary or barrel cleaner. A lot of farms don't have them anymore. They're very expensive, unlike a lot of other cleaners. This one, I have anecdotal reports that makes it even more interesting. But of course, I can't go on about.
Hey, Elizabeth,
Yes.
what was the rate of cleaning? What was the rate of cleaning that you said?
3,000 pounds, 3,000 pounds an hour. That's the smallest.
Okay, great.
That's the smallest model, which is the one I got.
Okay.
And the farmers are already saying, Elizabeth, you cheapskate. But you can see the if you Google Sosnowski Cleaner, there's now a distributor in Ohio. They're very nice people. And I'm not selling this, but it's just something to think about if you are looking to extend or get a first cleaner, and you want to buy new. This is the only new one I advocate for. Anyway, here we are with what I think everybody should be always swooning about. These are the standard cleaners, the mighty air screen cleaners, and you can see they come in all different sizes. The one in the middle is the kind I use. I bought it for $200 over 10 years ago, I think, and it's still going strong. You can pick these up. This is what I advocate that you do, is get a used air screen cleaner. They range in price from $100 to $3,000, but if you find a good one, it's worth its weight in gold. So you can see even a very old German seed equipment company. And somebody bought that Petkis at an auction a couple of years ago and has been happily cleaning with it since. I can't remember exactly what he paid, but I think it was well under $200. So with these, of course, the most important thing is to make sure that you have a good set of screens. You can't do it with 4 or 6 screens. You're going to have to buy some screens probably, but there's some excellent screen companies in the United States, happily, and there, if you want to learn more about that, there's information on the Ogren website. Okay, let's cut to the chase now. We're going to talk about dehulling. And when last I left you in 2015, the group of farmers that I work with, I call them the Beef Trust, because they do all the mental and creative work, and I blather about it. We're looking for dehulling capability for these ancient wheats. And I came across on an Amish farm this Stutzman dehuller. I may have mentioned it in 2015. We're just starting to work with it then. It was made to dehull spelt and sunflower. And in fact, it can dehull spelt and sunflower. It can also dehull einkorn. It's really lousy at spring emmer. And the price was right. You can see that the base model cost about $600, and then you either have to fit it with an engine or a motor. I always put it on wagons so that I can move it around both on my farm and from farm to farm. Now, we improved this. You can see on the right there the mechanism, which is very, very simple. It's a rotating drum fitted out with cut off pieces of RAS bars from combines, from used combines, old combines. So one of the things we did is we put more RAS bars on and we improved the efficiency. And again, this has terrific throughput for spelt. Again, 3,000 pounds an hour. That's pretty good. There are 2 problems. One is the efficiency. The efficiency was tested by Lamar Stauffer. Now, these are single replicates, but nevertheless, he did a lot of work. So he was growing Sungold spelt and he was growing Oberkomer spelt. You heard about Oberkomer from Sylvia. It's a lovely spelt. I like all spelts, but it's a nice one. And what he did is he put a known quantity of each type through the Stutzman dehuller, and then he cleaned it and put through the material that hadn't dehulled, cleaned it again and put it through once more. So this has been through the Stutzman dehuller 3 times. And after 3 times the Sun Gold Spelt, he got about 66% of the kernels by weight dehulled. You notice that the Oberkomer Spelt was only 53%. That is what we know about Oberkomer. Spelt varieties differ widely sometimes in their dehullability. Oberkomer really hangs on to its hull. So that was one problem. That's a fairly low efficiency. And the other problem is that it tends to have a very high cracking rate. If you run it at 3,000 pounds an hour, you will definitely get a lot of grain cracking. And grain cracking is a problem. It's not such a problem if you're going to make flour immediately. But if you want to sell berries, and berries fetch a good market price, consumers don't really want a lot of cracked kernels. And there's method to their madness. It's not just a visual thing. It's that the more your grain is cracked, the sooner it's going to start to become rancid. So we try to avoid cracking. We're always looking for methods that will reduce cracking. All right, so when last we met, we were also still trying to follow this method, which I still think has terrific potential, and that is converting old burr mills to dehullers. 2 different farmers working completely independently had thought this idea up on their own, and I've seen other little indications on the internet that other people have tried this. It's a very good idea because used burr mills, which are essentially feed mills, are a dime a dozen. They cost very little. And if you can see on the right side of your screen here, those 2 metal plates, those are the burr plates. You can replace one or both of them with rubber. And then you've made yourself a nice little dehuller. This is extremely cheap, and there's minimal cracking of grain. It's a very gentle abrasion system. So it has a lot going for it, but there was one problem, which you can probably have already anticipated. The rubber that these guys were using was horse mat rubber, was not food grade. And although it was very tough, and they could see over time that although they couldn't see remnants of the rubber in the dehulled grain, they could see that the rubber mats were wearing out. And also when they ran the dehuller very fast, they sometimes smelled burning. So we stopped at that point and we looked for another food grade possibility, and we thought of food grade urethane. Actually, Nigel Tudor thought of food grade urethane. You can get it in the same durometer as horse mat rubber, but we were so excited about this, and then what happened? It disintegrated before our eyes. So this is a very good idea, but we're stymied, and if anybody has any suggestions for a food grade material that would take that kind of beating, please get in touch with me. However, you can always, I talked about this last time too, I'll soon get to new stuff, don't worry. There are larger scale commercial dehullers available. The Codema, for example, which is manufactured in Minnesota, is a good dehuller. It's an impact dehuller. What I mean by an impact dehuller is that the grain is thrown against a metal ring at high speeds, and the idea is then the hull is loosened and will separate from the seed. Codema oat dehullers are going for, it's difficult always to get a good price quote from them, but it's going to be somewhere around $14,000 to $16,000 for the machine. So these are expensive machines, and you'll see how well they work in a minute. The Forsberg 15D, also manufactured in the United States. The last time I checked the price with them, it was around $10,000. That was 4 or 5 years ago. It may have gone up. I've tried the Forsberg 15D dehuller with one of the ancient wheats, and I was not happy. None of these machines, the Codema or the Forsberg, are listed for the ancient wheats. They're listed for things like oats. But before you get a Forsberg 15D, maybe talk to me. Now, the next one, there is no question that this is a superb dehuller. It's the Horn Spelt dehuller. It's manufactured in Germany. It's an abrasion dehuller. I'll show you how it works in a minute. These are wonderful. They have built-in gravity tables. I mean, this is creme de la creme. The problem, of course, is the price. I just checked the price on their website. Right now, if you bought it in Germany, you would spend about $36,000 for just the basic model. So when you can import, you can. I think there's at least a distributor in Canada. There may be one now in the United States. You can buy them. They dot the landscape. They're lovely machines, but they're quite expensive. And then finally, the Roskamp oat dehuller. That's a great machine. I don't have a picture of that. In the center is the Forsberg D. The thing that looks sort of like R2D2 is Kodima, and the conglomeration of tubes and intriguing German minimalism is the Horn dehuller. The Roskamp oat dehuller you can get used. And about 8 years ago, if you could get a used Roskamp oat dehuller, you should buy it. Now the prices have skyrocketed. So you're well over probably $7,000 to $8,000, maybe more for a Roskamp. So that's what I find the problematic with this type of dehuller is the cost, especially for a small scale grower who's just getting into this. So we wondered what we could do. And our mentor was Nigel Tudor, who when he started to grow Spelt, and he's now dabbled in einkorn and a little bit of emmer, realized that he needed a dehuller. Now, Nigel is a farmer. He's also a blacksmith, and he strongly denies that he's a machinist. Do not believe him, because he comes up with great machines. The Horn dehuller. Remember, that's the big enchilada dehuller. And he minimized it. He made it into, I'm waiting, my connection is unstable. He made it into a small scale dehuller using the same mechanism, same design. The only thing it doesn't have, unfortunately, is the gravity table. And he thought, he did this with an NE-SARE grant, a farmer grant, and I was the advisor on that, so I knew a little bit about what he was doing. And he wanted to make it for about $7,500. Instead, it cost him around $13,000. But it is a magnificent machine, and you can make it. He has given me the CAD drawings and the instruction manual. And if you're interested in looking this over and seeing if you could make a version of this, just write me an email and I'll send you all this information. Somebody who did that, somebody who was really intrigued and desperately needed to dehull einkorn, got in touch with Nigel, then got in touch with me, and he started to make his own version of Nigel's miniaturized Horn dehuller. And Henry is, I think, on his 3rd or 4th iteration now. Henry Byler is his name. He lives in north central Pennsylvania, and he is not a machinist, but he is really, really, really good at working through problems. And so he has made a dehuller that's based on Nigel's design, and you can see now the guts of what the Horn dehuller does, what Nigel's and what Henry's does. And this is an abrasion dehuller, but it's a special type. It uses flails, in this case 2, but now Henry is using 4. And the flails push the Spelt against a stainless steel wire mesh that's carefully sized. And that then, as they're pushed through that mesh, they are against that mesh. In some cases, they're dehulled. And this is really a brilliant, brilliant method. And it's not patented. So what Nigel did and what Henry did is perfectly legal. And when you talk to Nigel or Henry, you'll see that they have specific methods that they use for each ancient grain. So for example, Henry steel for Spelt, wire mesh for Spelt. Both of them seem to get their materials from Cleveland wire cloth. Henry is now making these. You can order one from him. He's in a redesign. It's at his designers. He's using all computer aided design stuff to make it very very professional. He thinks that this new one will be about $4,000. This is what he calls his large scale dehuller. This will do around 300 pounds an hour. And this works extremely well. Well, you're going to see how well it works. So here is some of the research that Ogren has been doing. By the way, is my list of participants my entire screen? Can you see my entire screen?
Yes.
Okay, sorry. I can't, but I'm muddling through. Okay, so here are these are preliminary results. My farmer advisory team and I wanted to test some dehullers, farmer made against some of these commercial types to see how well they performed, because this kind of testing is very rare. So what you're seeing here are preliminary results of the dehulling experiment using Oberkomer Spelt. We've also done some tests with Emmer and with Einkorn, but because you're interested in Spelt, we thought we'd tell you about Spelt. So Oberkomer we chose because it's difficult to dehull. We thought let's swing for the bleachers here. And I have two more dehullers to test. I have another farmer, and unfortunately I don't have the data yet from the horn dehuller I'm going to test. I apologize for that. But at least you can see some of the preliminary data, and it's interesting. So you can see 3 dehullers listed here. The first 2 are abrasion. The third is the Kodima impact dehuller, which Joel Steigman very kindly let me use at Small Valley Milling. And what we did is we put through multiple samples of this Oberkomer Spelt. Now this Oberkomer Spelt was grown by one farmer in 1 year on one field. So it's the same Spelt that's being tested in all these machines. So what we did is I weighed up 10 kilogram samples, and we put multiple samples through each machine. And what you're seeing here is the percent, the first column with numbers is the percent total sample recovered as grain once through the machine, just once through. So you're seeing that all of them recovered about the same amount, which is about 75% of what went in. So this is one clue for farmers. If you're wondering how to compare Spelt yield in the hull versus like a wheat yield or something, you're going to lose about 25. And in some of the literature, it can go up to 35%, but this is a good recovery. So here these folks are getting around 75% recovery of the sample that was put through. Now of that sample, and this is what's taking me so long because I'm having to do hand separation, which takes a long time. But what I've discovered so far is that the Tudor and Byler abrasion horn type are doing have an efficiency of 95% of the grain that goes through that dehuller, or that is recovered from the dehuller, is hulled. That is very good. That's excellent, in fact. The Kodima is not quite as good, but 90% is pretty good. I'd take that any day. That's of course a different kind of dehuller. Now the last column is very, very interesting because Tudor and Byler abrasion dealers have very, it's blocked for me, but if I'm remembering correctly, the Tudor had less than 1% of the grain that was dehulled, less than 1% of it was cracked. Call out if I'm getting that number wrong. And of the Byler, 1.75%, still very, very low amount of cracking. Now, here's the difference. With the Kodima, much more cracking. Now, why might that be? Well, it's a different type of dehuller. And also, Joel Steigman doesn't grow Oberkomer. He doesn't normally dehull Oberkomer. So we did spend some time running extra grain through. He was changing up the speed and so forth. So it may be that if he had a day or two to further refine his controls, he might have mitigated that. But I am not surprised that the impact dehuller has more cracking than the horn abrasion types, because the horn abrasion types are known for their gentleness with the grain. So there's a lot more to do on that experiment, but I thought I'd at least give you some preliminary information. I wanted to make, I guess, two to three more points. I'm sorry to blather on. If you're having any questions, just call out to me. I wanted to make the point that so far we've just been talking about the dehuller. And in that part of the experiment, I stopped the grain once it had gone through the dehuller. But actually what you need is a dehulling system. And this is where a lot of people find themselves up against another hurdle. What do I mean by a dehulling system? When you run grain through a dehuller, you're left with a spaghetti mess. If it doesn't have an aspirator attached to it to blow off the hulls, the empty hulls, you'll have them plus the dehulled grain, and very difficultly, the undehulled grain. Notice that even those superb horn-like dehullers don't dehull all the grain, right? There's a certain small percentage left that is undehulled. So what do? Well, you create a system. So you attach an aspirator, and that's pretty easy and that's pretty cheap. The aspirator will blow off those hulls. But then you have to separate the undehulled from the dehulled spelt. And that's what gives people a bit of fits. So there are a number of things you can do. Here's Nigel again, clever guy. And what I didn't mention before, you can see where my cursor is circling. That is a Forsberg destoner used. And Nigel is using it. You can see that the spelt, the dehuller is leading into the destoner, and the destoner is separating the undehulled spelt from the dehulled spelt. Oops. I actually, part of my experiment will be documenting the efficiency of their system as well. I don't have that data yet, but notice this is a plate full of Nigel's spelt that has come through not just the dehuller and his aspirator, but the destoner. And it's not as easy to see as I wanted it to be, but there is only one. See where my cursor is? There's on that entire plate, there's only one kernel in the hull. Remember, he's getting very good efficiency one time through the dehuller, and his destoner is apparently doing an excellent job on separating the dehulled from the undehulled. Now, how much did that destoner cost? It was used, like all good farmer mechanics, machinists. Nigel goes for used, but I think it did. I have to ask him precisely how much he paid, but it wasn't cheap. It was several $1,000s. Now, what does Henry do? Henry is Amish, doesn't have any electricity. He's using a hydraulic system, and he's using classic separation technique. What is this? This is an ancient fanning mill, which is the precursor of the air screen cleaner. This fanning mill has only one screen, a scalping screen. So here's Henry's dehuller. Here's his aspiration system blowing off the empty hulls. And then it's pouring out the rest of the crap onto the scalping screen. And he has found a perfect match for his einkorn in terms of a wire mesh screen size. And either he or I can give that to you if you're interested. He also has suggestions for spelt as well. And so it goes through the scalping screen, and that's all he does. And so both he and Nigel have a system whereby the undehulled is collected and then put back through the dehuller, because they're frugal farmers and they want to get every dehulled grain they can. But this is a plate of Henry's einkorn in this case, because he didn't have his spelt screen on. And here you can see that Henry's fanning mill is not doing quite as good a job as Nigel's destoner. There's one, there's one, there's one, there's one. Now, Henry sells to both commercial outlets, but he sells a lot direct to consumers. And so far, nobody has complained about this. Most of you that have made any of these as berries realize that if you put them in water, and then in a few minutes, any undehulled kernel will float to the top and you just skim it off. So far, Henry has not had any quality complaints, but that is clearly more undehulled kernels left than, for example, what Nigel has. But then Henry is working with a probably 100, 120-year-old fanning mill. Okay, I just wanted to go back to the Kodima and talk a little bit about the genius of the Small Valley Milling folks. Small Valley Milling, for those of you who don't know, it's near Harrisburg, Pennsylvania. It's a commercial enterprise. It's really mechanized. And here you can see the Kodima. It's in part of a system. And the Kodima, the dehulling system in this case, it's fed into a Carter Day aspirator and then into a paddy wagon. I didn't have a picture of their paddy wagon. And they also have a gravity table as needed. So this system, how good is this system? Remember, it's cracking more kernels, right? But their separation system takes care of that. So when they want to produce whole kernels to sell, this is what they produce. Very nice. Now, those of you that are looking at it, you're saying, is that Spelt? No, that's Emmer. That's all I had a bag of in the house at the moment. But you can see that on that entire plate, and I can guarantee you, there is not a single undehulled kernel. Now, they would tell you, they'd be the first to tell you that in a 5-pound bag or a 10-pound bag or a 50-pound bag, there will be the occasional undehulled kernel. But their quality control are commercial entities, which tend to be a lot finickier, especially when they're trying to lower the price, than consumers who you sell to directly. Anyway, I just wanted to show you that. Now, I've been talking a lot about gravity tables. Remember that the Horn dehuller is famous for having as an integral part a gravity table. You can buy gravity tables, but it's one of the great failings of our project to date. We really thought we could come up with a cheap gravity farm because it's a superb piece of equipment. It cleans grain and it does the separation technique. Now you can buy really cheap old gravity tables like the Forsberg here. It's tiny. It's not very good, but it does some good. And then you go up to the very fine Oliver line. The new ones are prohibitively expensive, but you can buy used Oliver gravity tables. They can be superb, but still, the last time I heard somebody got a used Oliver gravity table or a Forsberg gravity table for less than $5,000 was about 8 or 10 years ago. They're not cheap, even used. So we're working on this, but if anybody has any suggestions, let me know. That would be just a major breakthrough if we could get more of these machines dotting the landscape. Those of you that haven't seen a gravity table work, it tilts in several directions. You can vary the shaking, you can vary the airflow, you vary the intake feed. It sounds complicated, but 45 minutes or so, you've got it down, and then it just does an excellent job of separating, and it can also clean out some really bad weed seeds and stones. And if you are working with a dehuller that's doing cracking, if you have a gravity table, you're really in clover because it does a great job of sizing sections pretty easily. Some of you may have already seen this slide. You can produce the large whole kernel spelt, which you can sell as berries, and then you can use the smaller kernels and some of the cracks for flour. I just wanted to mention one more thing that Henry is doing, which is blowing open the accessibility of affordable dehullers. He is now making something he calls a trumpet mill dehuller. Here you see on the left, you see this romantic schema that he came up with. And here's the actual machine. You can see the intake. It's This one is powered by a 10 horsepower motor and it has a variable speed drive. Ogren bought it to circulate to farms. What's great about it, just lifts off. And then you can put in a dehulling screen if you're going to dehull, or you can put in a fine mesh milling screen and hammer mill out a very nice flour product. So this is really for the small scale grower. It can give you a lot of processing capability for relatively low bucks. How much does he charge for this? $1,375. Now that's without power. So if you're handy and you can make a drive one, it'll cost you whatever, you know, the motor or the engine is going to cost you. If you're not handy, he will motorize this and provide a variable speed drive, because you do need the variable speed for about $2,500. So if you're interested in a small scale dehuller, this is a very good option. And here you can see one of his earlier versions. This is his earlier version of a mill in action. So I've blathered on a lot. If you're interested in any of these machines or discussing options to build your own, or you have ideas, or you have a wonderful machine that makes some of these look like petunias, please get in touch. If you want more information, just contact me through ogren.org or via email. And I couldn't leave you, even though this has nothing to do with Spelt. This is one of our big success stories. This is an oat roller. The oat roller itself costs $500, and again, you just have to motorize it. It uses these knurled rolls. You grow your hulless oats, you clean your hulless oats, you put them through the oat roller, bang, you've got a saleable product of raw rolled oats. Anyway, that's enough from me.
Thank you, Elizabeth. As always, that was great. And I want an oat roller and a huller. Guess I'll have to send you an email. So I'm assuming you order through the various folks you were talking about. They don't have, they're building them as someone orders. Is that correct?
Right now, their trumpet mill dehullers, I think he has about 5 in stock.
Okay. Yep.
The big dehuller is in the redesign process, but he said feel free to call him. The man that makes the oat roller is another Amishman. His bishops will not allow interactions with us, so you have to contact me and then I contact him. But Ogren gets no profit out of this.
Yeah. Okay, that's great. Well, everyone, we're closing in on time. I know there are a few questions for Elizabeth. Why don't you unmute yourself and ask? My chat box got erased somehow. But I think there was a question about, I don't remember now who asked it. Somebody was asking it. I can't rember. I don't know.
Somebody was talking about somebody was talking about a snowblower. They work, but the efficiency is going to be, not as high.
Mm-hmm.
You can use a snowblower, but I wouldn't try to use it on something like Oberkomer, something that's very tightly held, or a spring emmer. It's not going to do much.
Henry, did you see the other question?
Yeah, there's a question or maybe a suggestion. If you've tried using leather instead of rubber in the Burr mill dehuller, that might work.
Yeah, that's interesting. I'm still a little worried about getting shredded leather into the final product. But if whoever that is that made that suggestion, maybe we could exchange some emails, because I think that method, if we could just come up with the perfect. Somebody suggested to me dried silicone, just putting silicone into molds and letting it dry. I haven't tried that yet.
Cool. I don't know, Henry, if you could put Elizabeth's email in the chat. I can't myself, but so that way people can reach out to her. Elizabeth, thanks so much. I'm so glad you're continuing to make so much progress on small scale hulling and oat rolling. It's always great to get your updates. And hopefully we'll be able to see each other in person again sometime soon.
Yes. You're too young. You're too young, Heather. You gotta be a gray hair like me.
I don't know. I've gained a lot of gray hair over the last year. I realized that. Oh my goodness. Well, thank you again. And it is 2:00. So we'll sign off for today. And if you have questions, you have everybody's emails, please feel free to email them. And then on Friday or tomorrow, we'll be joining Jeffrey and Sylvia for some lessons on working with Spelt and how to bake with it. So thanks, everyone. Enjoy the beautiful day. Bye.
Bye-bye.